Okay, in class we did raw data, organizing and graphing qualitative data, organizing and graphing quantitative data, and shapes of histograms, and maybe cumulative frequency distributions. Let's quickly review that. So raw data, uh, data recorded in the sequence in which they are collected and before they are processed or ranked is called raw data. Okay? Organizing and graphing qualitative data. Now, we talked about the difference between qualitative and quantitative. Um, so if you have qualitative data, how can you graph it or organize it? So let's take the type of employment students intend to engage in. So some students will engage in private companies and businesses. Some will work for the government. Some will work for state governments, and some will own their own businesses. So these are different. The variable that we're talking about is the type of employment, and then the values that it can take are not numbers, right? We don't say like the type of employment is 6. No, we say the type of employment is private company, or the type of employment is federal government. So that's also, it's like, for example, the flavor of ice cream that you like. Okay, so the flavor of ice cream that a person likes is the variable. And the values that it takes are not numbers, right? We don't say I like 7, right? We say I like chocolate, I like strawberry, I like vanilla, right? So the values are not numbers, and so this is called quantitative variable, a quantitative variable. So uh, how can we express, give some kind of graph for that kind of variable? So we take the frequency distribution for qualitative data. Frequency distribution for qualitative data lists all categories and number of elements that belong to each of the categories. So we're going to list all of the different categories like we did here, and then how many people, in this case, fall into each of the categories. And that's called a frequency distribution for this qualitative variable type of employment. Example 1. Constructing a frequency distribution table for qualitative data. So a sample of 30 employees from large companies was selected. So we select a sample of 30 employees. So these are the so-called individuals in our sample, and we're gonna talk about a particular variable and sort of apply it to these employees. So the variable that we're going to do is these employees were asked how stressful their jobs were. So that's the variable, how stressful the job is. So there's different values that that variable can take. So this could be a numerical variable, right? You might say there's 0 stress, 1 unit of stress, 2 units of stress, 5 units of stress, and so on. It could be numerical, but we're not going to treat it that way. The answers are going to be given like somewhat, very stressful, not stressful. So that's not numerical. So if the answers are given that way, how do we deal with it? Okay, the responses of these employees are recorded below, where very represents very stressful, somewhat represents somewhat stressful, and none stands for not stressful at all. So now how can we make a so-called frequency distribution table for this qualitative data? So we make something like this. We say, what are the values that we write the variable up here. The variable is called stress on job. And the values it can take are not numbers. The values that it can take are very, somewhat, and none. Okay? So, by the way, when we have different when we have a quantitative variable like, say qualitative variable like this, um, the values that it can take are often called the levels of that variable. So the levels are very, somewhat, and none. So then we make what's called a tally, which just means we count up how many were there in the how many answered very, how many answered somewhat, how many answered none. That's called the tally, and then we count those, and we get 10, 14, and 16. Of course, that should sum to 30, and this is called the frequency distribution of stress on the job. And the relative frequency of a category is just, you take the 10 over the 30. 10 out of the 30 were very, 14 out of the 30 were somewhat, and 6 out of the 30 were none. So you take the frequency of that category divided by the sum of all the frequencies, and you get 33, because it's 10 out of 30, 14 out of 30, and 6 out of 30. You get this. Of course, it sums up to 1. And then if you change it into percent, then it should sum up to 100. And then we can make a graphical presentation of this situation. So we just have a category called varies, a category called somewhat, and a category called none. And we'd have the heights of a bar graph as 0.33, 0.46, and so on. So we get this, right? Very, somewhat, none. And we saw that what? This one was 46%, that was the highest, and so it's the highest here. Okay? Okay. Okay.